All points lying inside the triangle formed by these 3 points 1, comma 3, 5, comma 0, and minus 1, comma 2. They satisfy which of these following equations? Right. All the points, if all the points in a triangle are lying on one side of any one of these equations are basically inequalities based on straight lines. Right. We have a straight line like this, and 3 points of a triangle, all 3 points are on the same side of this straight line, then obviously all interior points of the triangle will also be on the same side of this line, right? So 2 points, whether they are on the same side or on the opposite side, we will know when we substitute those 2 points in the equation and see whether we are getting the same, we are getting positive result or negative result, or right. So for example, for a line, if a point, if these 2 points are like this, if both are on opposite sides, so one of them will be positive, another will be negative. If you substitute both the values of x and y in this equation, one of them will give positive result, another will give negative result. This is positive, this is negative. But on the other hand, if both are on the same side, then that means both will be positive together or both will be negative together. It cannot happen that one is positive, one is negative, right? So that's how we'll identify whether 2 points are on the same side of a line or not. If they are on the same side, they will have the same signs when we substitute those 2 points in the given equation. So basically, what does that mean? These 3 points, if they are on the same side of whatever this lines, then that means all 3 points will have the same sign when we substitute those values of those points on the given lines, right? So we have these 4 lines. Let us try to see how these 4 lines look. For example, 3x plus 2y minus 3x plus 2y greater than or equal to 0. That is this green line, and this green line, and what is the area that we are talking about? Let us substitute, let us take one random point. So for example, 1 comma 1. 1 comma 1 is greater than or equals to 0. 3 plus 2, that is 5, is greater than or equal to 0. So this equation is satisfied for all the points on the side of 1 comma 1. So for example, 1 comma 1 is towards the right side of this line. So the region we are talking about is the region towards the right side of this line, the region in which this point 1 comma 1 is staying, right? That is the shaded region. This is the area, that is the region that we are looking for, right? So each line will have two sides, either this side or this side, right? And when we substitute any random point in this line which is not on that line, any random point which is not on the line, and then we will get some value, right? You will get either a positive value or a negative value. If you are getting a positive value, because then that means this statement is true. For example, if you substitute 1 comma 1, then that means 3 into 1 plus 2 into 1, that is 3 plus 2 is 5, which is greater than or equal to 0. So that means the statement is true. That means 1 comma 1, we are talking about the region in which 1 comma 1 is lying. 1 comma 1 is lying in the right side of this for this straight line. So that's why we're talking about the right side region of this straight line, right? Similarly, if we talk about minus 2x plus y is greater than or equal to 0, right? Then we'll take some random point, for example, 0 comma 6, right? 0 comma 6, when x is 0 and y is 6, so then that means 0 comma 6 is satisfying this line, right? So 6 is greater than or equal to 0. So that means you are talking about the region in which 0 comma 6 is lying. So that is towards the left of this black line. So that is this shaded region, right? And similarly the other two lines also we can substitute, so for example in this we can substitute 0 comma 0 origin, when you substitute, then minus 13 is not greater than or equal to 0. So that means origin is not in the region that we want, origin is on the other side. So that's why we are taking this region, we are not taking the region for this line in which origin is included. So we have to take the region in which origin is not there. That's why we are taking this region. Similarly for the fourth one also, for the fourth one, 2x minus 3y minus 12 is less than or equal to 0. When we substitute origin, 0 minus 12 is less than or equal to 0, which is true. That means the region we are talking about includes origin. So that is this region. Right. So basically, we know what are the four regions. Now, what does that mean? What is it that is asked? All 3 points, if they are lying on the same side of these respective lines, these lines, then that means every point in the triangle will be on the same side of this line, right? All points lying inside the triangle, it is redundant, right? We don't need to check each and every point within the triangle because there are uh, because uh, because this is a triangle. Right. If all the 3 points are on the same side, then obviously entire triangle will be on the same side of this triangle. So now if you substitute in this one, if you substitute, you can clearly see in the diagram also, right? It is satisfying this line 3x plus 2y, that is this one, and it is satisfying. It is not satisfying this line, right? This area we are not it is satisfying. Then it is not satisfying this black line, that is minus 2x plus y, because one point is definitely on the other side. A and C are on the same side, so it is not satisfying this line. And in option B, we are talking about this region. Clearly, the triangle is not in this region. The triangle is on the other region. So this is also false. And 2x minus 3y minus 12. 2x minus 3y minus 12. That is this one, this line, this region. Yes, the triangle is within this region. So this is also true. Basically, two are true and two are false. If the question was about whether they are on the same side of the line, then this also would have become true, because only this line is passing through the triangle, right? For all the other ones, it is the triangle is on one side or the other side of the line. But here the question is, uh, all points lying inside the triangle satisfy this equation or not. So because it is about satisfaction of the equation, that means we have to ensure that the triangle is in the respective region also. In this case, though the triangle is on the other side, but it is not falling in the region. If this was less than or equal to 0, right, then this statement also would have been true. Right, guys?